Good morning. We're going to do question 169 and 170, so let's do it. They look like this. Make sure you're on the right page here. We have two questions. One says, after a snowstorm in a large metropolitan area, the meteorologist took a random sample of several locations and measured the depth of the snow along with the water content. The results were summarized in a computerized output. So it looks as if they measured two quantitative variables. So they came up with a least squared regression model, and this is the formula for the least squared regression line. Notice the output gave us r squared and r. So if r is, and so that's a very high value for r, notice that they did a lot of this math for you. You could double check their math if you took 0.97478 and you squared it, or took it, multiplied it by itself, you would get this value. So, what else did they calculate for us? Well, it appears as if they've given us the degree of freedom and they gave us the t-value, but something happened with the printer and the p-value didn't print out. Is this something we'd be able to do ourselves? Well, it says here that the p-value for the hypothesis test is the slope 0, so that's always the p-value. We came up with a slope of 0.103, but was that purely random? Well, our hypothesis test states if it was random, then the average slope would just be 0, or maybe there's absolutely no correlation between the two. And then the alternate test, it's something other than 0. So notice this is a two-sided test, and that's going to be important here in a minute. So would we be able to do, we rely so heavily on our calculator, would we be able to do this if our electronics failed us and didn't print this value? So we know we have to go to 4 degrees of freedom, and we know the t-value is 8.610. So let's scoot right along. Here's my t distribution. This is my distribution of t, and there's my tail probability. So as I scan through here on the number 4, which is my degree of freedom, and I look for the value, there's the number right there, 8.610. So the value of t, 8.610, came right off the chart there, and the degree of freedom came right off there. And when we look at the chart, that's exactly the number we see. So we recognize that the probability of that outcome, even if in fact it is true that the slope is 0, the probability of that outcome is 0.0005, right there. So I'm just going to make a quick picture on my sheet. Whoop, okay. 0.00, one more 0, 5. But that would be the probability if I hypothesize that the slope is something greater than 0. And notice my information, I did get a positive value, but that's not how they wrote the question. They had said they wanted you to do a hypothesis test for something if the slope was something other than 0. So you are okay whether it's positive or whether it's negative. So if you can think about folding this in half, you know that the probability of the slope being negative would also be this same value. So this would have been the answer, which is actually not one of my answers, but I would have had to go with A, because that number, well, actually, yeah, that number is less than 0.001. So I would have had to go with A if they said a one-sided test, but they definitely said a two-sided. So when I add these two values, I get that. So I'm going to go with answer B. That's the probability that the computer would have come up with had the computer not failed the print job. Next question. 170 states a monthly power usage in a rural area is given by this least squared regression line. So another least squared regression line test. And it states that Y hat is the number of kilowatts used, and X is the number of months since January 2000. Okay, so they're wanting us to estimate. Oh, this is kind of handy too. They said, so for instance, let January 2000 be X equals 0. What is the estimated monthly power usage for December 2002? So this gets a little difficult, kind of. You're trying to figure out, okay, so January 2000, X is 0. That would mean February 2000, X is 1. So I'm just going to keep going here, just kind of jotting down February, March, April, May, June, July, August, September, October, November, December. I want December. Now I want December 2 years from now, but let's figure out what that would be. So in February would be 1, so March would be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So December we maybe think was 12, but it's not because we're making January 0. December would be 11. So that's December of 2000 would be X is equal to 11, but they don't want December 2000, want me to keep going. So that would have been 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So it's basically, I added another 12 there to 11, and that would be for December 2001. So to get up to 2002, I just need to add another 12, which would be 35. So just 1 month shy of 36 months, which is the same as 2 years. Okay, so now I know my X value is 35, so now I'm simply going to plug this in, and that's a basic math problem. I'm taking my simple calculator. I take 1.01 times the number 35, because that's 35 months later, and then I want to add my y-intercept, 2.7, and I get 38.05, which is in fact my answer. Thank you for joining us.